So, as we have our topic of heat, it is very important that we continue working with the volumetric change in liquids. As we are working with liquids, it is important just to do understand the basics of what is happening whilst you are working with the liquids, just like what we had when we were working with the solids in our previous case. So we are going to notice some differences from what we had. Remember, liquids, we are dealing with something such as water. We can talk of oil. We can talk of paraffin. These are liquids. When a liquid is taken into a container, let's say we have got a certain container, and you pour the liquid inside the container, you are going to notice that the liquid that we are having inside, this liquid, it takes the shape of the container. Maybe you filled it up to this point. It will be taking the shape of the container up to that point. Meaning to say, if we are to pour the liquid in a container of this nature, it's a drum, it's a cup, it's a cylindrical container, it is going to take the shape of that container that it is inside. That's the liquid. That's the part of a liquid. Different from what we had when it is a solid. You are dealing with a certain material, a metal, as it is subjected to heat. We're going to just have an expansion to that material only. There's nothing like a container involved there. So when dealing with a liquid, because we are saying here, because liquids, all right, because liquids take the shape, because liquids take the shape of the container, because they take the shape of the container only, all right? So here we're going to say only their change in volume is considered. Only the change in what? In volume. So actually, this is another statement that I was going to mention. All right. I was going to mention this one later on. No problem. As we have the liquid, it is in a container. The container is a cylindrical container, whatever container that you have. So you must consider the volume as it fills in. So only the volume. So as we consider the volumetric change of liquids, we are not going to change, we are not going to talk about any change of length, any change of area. No. It is only volume. Only volume is going to be considered. All right, no problem. We're going to go back to that statement. I was here about these two things here, the container and the liquid. You will find out that the liquid, when it is expanded, when a liquid expands because of a change in temperature, the container will expand because of its pressure. So this one expands because of what? Temperature. Because of change. Because of change in temperature. Let me just write that way. Because of change in temperature. But the container is going to expand because of the pressure. The container will expand too because of its pressure. So this one expands due to pressure. Due to pressure, it also expands. So there are two things here to be considered. There are two expansions to be considered. There's an expansion of the container. There's an expansion of the liquid, meaning to say there is a change in volume which affects the liquid. There is a change in volume which affects the container. Guys, we must be very careful there. Very, very careful. A change in volume for the liquid, for the container, due to pressure for the container, due to the change in temperature for the liquid. So we know, guys, the formulas, they do not change. The change in volume, we still go back to those formulas that we had. So that is why I'm not focused on those formulas. You know those formulas. I want you to understand what is happening here on this part, because it is going to affect later on when we refer to something such as an overflow, if you understand this part. An overflow is happening when the liquid is given like this. We have got a container. The liquid is there, all right? This is our liquid. Takes the shape of what? The container. Due to temperature, the liquid expands, all right? Due to temperature, we notice that the liquid expands such that it turns that some of it is even going out of the container. There is an overflow. Some of it is going out of the container. So what can we actually say about an overflow? If we are to consider this, like I said, I was going to talk about this, but let's consider the overflow. The formulas, guys, I'm going to write those. They are the ones that we used for volume. They're not going to change. So let's consider what is important on this part. The overflow, if we go back to the container as it is right now, originally as it is, the container has its volume or its capacity, what it can carry. That is the capacity of the container. It has its own volume. It can carry up to this point. What is inside is the volume, the capacity of what it can carry. So originally, this container has its volume capacity. We have the volume capacity of container. As it is originally. But the liquid, because of the expansion, originally it had a certain volume. Here, it is inside the check note. This is the liquid. So inside, we have got, what can we, okay, let me put it this way. We have got the original volume of the liquid. If you put it this way, you understand me. You have the original volume, which is of the liquid. But take note, the liquid now expanded, now it's overflowing. It's overflowing, meaning to say there is a change that happened in terms of the volume of the liquid. There is an increment which happened. There's an increment that happened. And whenever there is a change in volume to the original volume, we understand that the final volume has to be calculated, meaning to say the liquid, due to its expansion, has its final volume. After the expansion, it has its final volume. Definitely, we do understand, guys, final volume is from where? From the original volume that we had of the liquid plus the change in volume that happened for that liquid. The change in volume. So this will give us what? This will give us the whole part. This will give us the whole part. This will give us the whole part of the volume that we are having of the liquid. That is the consideration. So if we are given the final volume of the liquid, which is, it is overflown. Guys, we are saying the change here. This is the original volume, this one. Here, this one. It is this one that we see inside of the container. The overflow, it is just, the change, it is now the one that is coming out like that. So when you add the change, this one, to the original volume, that is where we are obtaining the final volume of the liquid, which is actually bigger than the volume capacity of the container. When there is an overflow, you are going to find out that the volume, which is the final volume of the liquid, this one, will be greater than, will be bigger than the original, the one that you had of the container. It will be bigger than the volume capacity of what? Of container. It will be greater than that one. So therefore, an overflow can be determined from there. So we are simply saying the volume overflow will be equal to, since the liquid, in an original sense, the liquid was supposed to expand up to the end here, up to the volume capacity of the container, what the container can carry. But in this case, it expanded to more than what the container can carry. So the difference, which is of the final volume that we had for the liquid, minus the capacity of the container, is our overflow. So meaning to say this one, it is going to be, this guys, I'm just going to write in short, the final volume of liquid, all right, minus the volume capacity of container, minus the volume capacity of what? Container. So this will be the idea. You have to subtract what the container carries. So the volume of capacity of the container, it is either they will give you, or you'll be given dimensions where you're supposed to calculate the volume. Remember, we talked about this, guys. A container can be in the cylindrical form, can be in a rectangular prism. You go back to those formulas that we stated that you can use when calculating what? When calculating your volume. So this is it. You are working with the volumes, but in some cases, they might not give us these volumes. They might not give us these volumes. So what happens is that if you are not given the volume, as the container, like I said before, the container expands due to pressure. It also expands the container. The liquid also expands. So we can deal with their expansions. You can work with their expansions. The expansion, since the liquid is the one that is caused an overflow, so it follows that the expansion of a liquid minus the volumetric expansion of a container will give us the same thing. So we're going to need also this formula. We can have it from the same, the change, which is the expansion, the absolute volume expansion of the liquid. All right? The expansion of the liquid minus the expansion of the container. Minus the expansion of the container. These also can give us the volume change from how these two changed. All right? So we are talking about what? Volume. All right, let me just write in short, volume expansion of liquid. Here we are talking about what? The volume expansion of container. That's, we can have what? We can have the volume overflow. So when a liquid is heated, it can expand to more than the size of the container. When it does that, there's an overflow. All right. So here, guys, I'm talking about the change in liquid, the change in what are these? How do you calculate these? Just like how we calculated before, the change in volume for the liquid, the change in volume for the container, it is the same way that you were calculating these change in volumes before. All right. So let us just have our formulas, because you might wonder to say, so there are no formulas for these ones. No, the formulas, they are there, just like what we had before. But remember, I said for liquids, you just deal with what? Volumetric change. All right. So let us just have our formulas. So the volumetric change in what? In liquids. So as we had the formulas, guys, remember the change in volume is equal to, we are going to use the expansion, which is for volume, just like what we had when we're dealing with any other changes. So we work with the volumetric coefficient of expansion times the original volume times the change in temperature. So meaning to say, if we are given this, and also remember that your volumetric expansion, this one is equal to 3 alpha as we had from the previous classes. So it follows that from this formula, guys, everything that you had is still the same. The only thing that you are now separating is that you can have a change in volume, considering, remember, we talked of a container. So for a container, because it is going to have its own expansion, its own increase in volume. So if it is that one, we're going to use container. I'm just going to use C to denote a container. So I'm going to write like this. The change in volume for the container will be equal to what? The volumetric expansion for what? For the container times the original volume. So take note, the original volume now is this one, not the volume of the container. No. That one, it is the capacity of the container. This original volume that we are talking about, it is of the liquid inside the container. It is the volume of liquid inside the container. That is the one that we are talking about. So we must be very careful. There is a liquid that is inside what? Container. Its volume. That is the one that we are talking about here. So this one is volume of liquid inside container. Originally as it was given. So do not confuse there. Times the change in temperature. So that's it. This one, do not confuse with this one that I was talking about here. Where did I list those ones? All right, sorry, it was this page. Let me go back here. Do not confuse with here. When I was talking about this expansion here, when I was saying the volume capacity of container. No. The volume capacity of container, it is what the container can carry when it is full. That's a full capacity. We're talking about the full capacity. So that is the volume of the container from the dimensions of that container, if you are given the length, the width, and the height. Not this one of the liquid. When the liquid is inside the container, its volume, it is also equal to the volume of the container for that particular section, not the capacity of the container. There are two things. There are two different things. All right. I just hope here, guys, you understand me. Let me put it this way so that all of us will be together here. Let me put it this way. This is our container. If we, okay, let's just take a cylinder. Okay, just like you have got a drum, all right? You understand me? Okay, maybe some of us, we are not used to drum. A cup, just like a cup or a wine glass. A wine glass, most of you, when you talk about wine glass, you understand. So in a wine glass, if you pour the wine or it's your beer that you are drinking, this is the beer that you pour inside the wine glass, all right? It is in the form of a cylinder. All right. When you pour the beer inside here, this one, it is inside. Is it the spelling for beer? All right. Or let me just write wine, guys. I'll end up writing wrong spellings. Okay. You pour it inside. It takes the shape of the wine glass. Meaning to say it has the volume because of taking the shape. The volume that it has of the wine, all right, the volume of wine in this case, that is inside of the wine glass, is the one that we are saying it is the volume of the wine glass at the level or height of what? Of wine. Not to say that is the volume of the wine glass. No, the wine glass is the one that you are having, that you are holding. When you talk about its volume, the wine glass, this one, when you talk about its volume, we are talking about, okay, this one is a cylinder. What is the volume of a cylinder? Pi r squared h. That is when it is full, when the height is at the end, when it is full. This one, when the wine was inside, it was inside to a certain height. It was up to a certain height. It was up to a certain height. So it was not carrying the whole part of the, it was not carrying the every part of the glass. It was not, unless they mention that it is full of wine. Then you know that that volume, when it is full, therefore it is no longer the volume of wine. It is now exactly the volume of the wine glass, meaning to say it is exactly the capacity of the wine glass when it is full. I just hope we are together now. All right. Anyways, you understand me when I'm explaining questions, because this section is another part that we have in our new syllabus, and it is very important for us to consider very much. So a container has its own properties, but those properties somehow they are being affected by what is inside. Because of what is inside the container, somehow those properties, they will be the same. That is what happened here. To say the volume of the liquid inside the container at that moment can give us the change of what happened to that container, because we are working with the liquid that is inside the container. But when this expansion of the container happens, and also the liquid, because remember there's also a liquid. So let us have for the liquid now. All right, so we're going to have the liquid. So for the liquid that is inside the container, we are going to have its change. So the change in volume for the liquid, let us just use the letter L for liquid. So we're going to have the liquid here. So definitely we're going to have the expansion for the liquid times the original volume, which is exactly for the liquid, times the change in temperature. So what just differed here is the volumetric expansion of the liquid. Take note. The volumetric expansion for what? For the liquid. This is the one that we are talking about. So if we have the part of the liquid on its own, this one, we've got its expansion. There's an expansion of what? Of the container. There's an expansion of the liquid. That is where we bring now the concept that I was talking about, to say when the overflow happens, it is because the expansion of the liquid is greater than what happened to that one. It is going far, much to what we had to the container. With these formulas that we have here, there can be a condition where they actually need you to determine the actual volume increase of the liquid in a container, the actual volume increase can be determined from the sum of these two, the change in liquid and that of the container. So for the best part of revising, I think question papers will be best. But like I said, use these formulas and the understanding of the overflow that happens. And like I said, sometimes they can ask you about the change in height. When we're dealing with the liquids, guys, we do work with change in volume. But when you know their volumes, because there are other containers that we can be told their volumes. Remember, volume of a certain part, maybe its base area times height. Whatever that you're given, there is a height there. So meaning to say, you must know the original volume and you must know the final volume, so that you go back to the original volume, you calculate the original height. You go to the final volume, you calculate the final height from there. Therefore, the change in the height can be calculated, because you just have final minus what? The original. It can be calculated. Those linear calculations can be done, but not in a direct way, in an indirect way. So this part I'm going to explain using questions. I think that can be best. And do not forget, guys, as long you are dealing with the volume, there is a change in volume. So definitely, sorry for that. Definitely you're gonna go back to the this volumetric expansion. They can ask you to calculate that one. So you're just gonna make it the subject of the formula, the change in volume over the original volume times the change in temperature. They can ask about the percentage increase in volume or the percentage change in volume. So we said from the change in volume over the original volume times 100%. Do not forget our previous classes. So that's it, guys. Let us meet in another class, as we shall be having examples. Like I said, this section, it is best that I work with questions so that you can understand some of these terms or presentations or formulas, but you need these formulas, as we shall be moving on in the next class.